Hello friends, let's learn what will be the magnetic field at the center of a current carrying loop. For this, we are taking here a current carrying loop. This is a loop. Let us have a cut here and this is the connecting wire. So current enter from this end, it rotates and it out from this end. Then what will be the magnetic field at the center point? To find this, let us take a tangent here. This is a tangent. This tangent have a elementary length dl. Let us join this to the center. The radius is r. Then this is at 90 degree. Now apply Biot-Savart's law. So according to Biot-Savart's law, you have dB magnetic field is mu naught upon 4 pi I dl sine 90 degree upon r square. Here 90 degree is the angle between dl and r. Now this is the magnetic field due to a small element dl. So you have to find the magnetic field due to whole loop. Whole loop have this length is the 2 pi r, that is the circumference. So you have to integrate it. Integrating, here we are giving the sign of integration 0 to b whole magnetic field dB, and on the RHS side mu naught upon 4 pi is constant, I upon r square is constant, integration 0 to 2 pi r dl. Then the integration of dB is b and the integration of dl is l. So you have here b, give a bracket here, write here 0 to b. On the RHS side mu naught upon 4 pi I upon r square, and here the integration of dl is l, give a bracket, write 0 to 2 pi r. Now this is b minus 0 is equals to mu naught upon 4 pi I upon r square, and l will be replaced by 2 pi r. So write here 2 pi r minus 0. So you have b is equals to mu naught upon 4 pi I upon r square into 2 pi r. So cancel the common terms, that is pi will cancel out. Here this r will cancel out, this 2 will cancel, you get 2 here. So what you get? B equals to mu naught I upon 2r. This is the magnitude of magnetic field. And direction of magnetic field is found by right hand thumb rule. Right hand thumb rule says that keep your right hand curled over the current carrying loop. Then the thumb will indicate the direction of magnetic field. I am repeating this. Keep your right hand curled on the current carrying loop such that the curl of the finger represent direction of current. Then the thumb will represent the direction of magnetic field. So here if you curl like this, then the thumb is inward. This means that magnetic field is perpendicular to the plane of the board. So when the magnetic field will inward, will indicate it with a sign cross. So give here a sign cross. This means that magnetic field is inward. When you have magnetic field outward, then you give a sign dot. For example, if this is a loop and if current is moving from this side, then put your hand on the current loop such that the curled finger indicate direction of current, then thumb indicate direction of magnetic field, it is outward. So here you have to give dot. Dot means magnetic field coming outward and cross means magnetic field going inward. This can also be found by clock rule. There is another rule known as clock rule. So direction of magnetic field at center of loop is found by number first, the method is right hand thumb rule. right hand thumb rule. And number second, the method is clock rule. Clock rule. Now, what is clock rule? It is a new thing for you. Let's understand clock rule. Here for clock rule, draw two circles. In one circle, current is rotating clockwise. So this is the direction of current, clockwise. On another circle, the current is moving anti-clockwise. This is the direction of current, anti-clockwise. So for clockwise, this represent south. See the arrow here. This arrow is representing similarly here. These two arrows are on the same direction. So if current will rotate clockwise, then it represents south. In the same way, here you have north. If current will moving anti-clockwise, then it represents north. So you know that current move one clockwise, then it indicates south, and when current move anti-clockwise, it indicates north. So now let us have a numerical based on this. Numerical number 1. Suppose I am giving you a wire. This is a wire, and in this wire current is moving 12 ampere. Current is of 12 ampere. Now this wire is bent in a semicircle. When you bend in a semicircle arc like this or like this semicircle, then current will move in this wire clockwise and in this wire anti-clockwise. So you have to find magnetic field at this point, and let the radius is 2 centimeter. Radius is 2 centimeter in both the case, 2 centimeter. Then in both the cases, what will be the current at the center, what will be the magnetic field at the center, and what will be the direction of magnetic field. Let it is figure number 1, this is figure number 2. For figure 1, since it is a semicircle, so you know that if complete circle is there, then the magnetic field is 2 pi r. So for semicircle, it is divided by 2. So magnetic field B is equals to mu naught I upon 2r for full circle. This is for full circle. Therefore, B dash is equals to mu naught I upon 2r into half. This is for semicircle. Now here it is semicircle, so this formula will be used. What is the value of mu naught? Mu naught is 4 pi 10 to the power minus 7. What is I? I is 12 ampere, right here 12. And here you have 2. What is R? R is 2 centimeter. So 2 into 10 to the power minus 2 is here, and this is 2. Now cancel this, 2, 2. So it will be cancel out. Cancel this, you have 6. So you have 6 pi into 10 to the power minus 5 Tesla. So in both the cases, magnetic field magnitude will be same, that is 6 pi 10 to the power minus 5 Tesla. But in case 1, the direction is, you have to find the direction, so you can use the right hand thumb rule. So according to right hand thumb rule, the direction is inward. So for inward, you have to give cross. This is here cross, inward. And here the direction is outward normal. So you have to give dot. So magnetic field, direction, magnitude in both the case are same, but direction in first is cross and in second is dot. Thus you have learned magnetic field at the center of current carrying loop and how to solve numerical on it. Do like, share and subscribe my channel. Thank you.